up till now, you've measured all of your angles in degrees. And now we're going to introduce you to a different way to measure an angle called a radian. Now, you've dealt with this different measurements before. Okay? Who knows how tall they are? Does anyone know how tall they are? How tall are you? 6 foot. Do you have a driver's license? Does it say 6 foot on your driver's license? He's 6 feet in real, but on his driver's license, he wrote 180. He's a giant on his driver's license, but just in reality only 6. How is that possible? What is it? Why is it on your driver's license that it's different? Different units of measurement. On your driver's license, it's centimeters. You're not actually 180 feet tall. That would be really scary. Oh, I lied. I lied on my driver's license that I wanted to be 180 feet tall, but in reality, I'm only 6 feet tall. Okay? And so we have different measurements. And so when someone says their height in centimeters, you have to convert that to compare it if they tell you how tall they are in feet and inches, right? And we only use feet and inches here in Canada and the United States. The rest of the world always measures their, well, in Canada, on all official things, we'll use centimeters for height. But unofficially, we still use feet and inches. Whereas anybody coming from other parts in the world will only know their height in centimeters because that's all that they use. Well, a radian is just another way to measure an angle. And a degree is arbitrary. Who decided there would be 360 degrees in a circle? Somebody. But it's arbitrary. They just took a measurement and decided that if you have two perpendicular lines, they decided that was 90 degrees, right? Why did they decide 90? You know, it's just made up, right? So there's someone who said, I don't like 90. I would like a right angle to be 100 degrees. And there's a unit of measurement that says in a whole circle all the way around is 400 degrees. And those are called gradians. We don't use those. But we do look at radians. And what a radian is if you take a circle. All right, so we're going to draw a circle here. Oh, I'm going to start with the center of my circle right here. And I'm going to use, this is a special kind of triangle. It's a little bent. But does anyone know what the name of this kind of triangle is? If all of the sides are the same, it's equilateral. So if I start with this as my, I'm going to just use this length as my radius, and I'm going to make a circle with a radius equal to the length of that triangle. Now I know that on the board with all of the different resolutions, it's a perfect circle on my screen. But on the smartboard, it's a little bit oval. No? Okay. So this, from here, whoa, that's another circle. We're going to get rid of that. From here to here, that's a part of your circle. What's that called? That's the radius. There's the radius of my circle. Now, if I take my equilateral triangle, which has the same side length as the radius, more or less. And if I push this down until my equilateral triangle bent so that it fit perfectly along the outside of the circle, this would also equal one radius on the outside. And that outside edge, we've talked about it already, that's called an arc length. Now, when your arc length is equal to your radius, we decide, well, we didn't decide, but this is the definition of what one radian is. So unlike degrees, which are arbitrary, that someone just decided there's going to be 360 of them around the edge of the circle, a radian is actually based on a part of the circle. It's based on the radius. And so if the same radius was on the outside edge of your circle, that angle is called 1 radian. And because we took a 60-degree equilateral triangle and squished it down, right now the best we can do for an estimate, it's a little less than 60. That's not very mathematically sound yet. We're going to get better than that. But if I took this, and I've squished this a few too many times, it looks like. But if I took this and squished it down, that's going to change that angle to be a little bit less than 60 as opposed to when it was straight. Perfect. So right now we know that 1 radian is a little bit less than 60 degrees. The first question we're going to do, so there you go, that's your definition of a radian. Do you feel like if I got you to jump up and turn 3 radians, you'd feel you knew how much to turn? Right? This would be, if I turned 3 radians, I would have to go another radius, maybe that much would be 3 radians. Okay? How many radians do you think are in a whole circle? Okay? Yeah, if I got just here at 3, it looks like I'm going to have 4, 5, here. That is good. Let's go. This is our estimation so far. This is how you start to do mathematics. There are 6 and a bit radians in a circle. Right? So right now, you're getting closer there. Okay? We're right now just estimating. And for someone taking pre-calculus to say there are 6 and a bit radians in a circle doesn't really feel like we're that good of a mathematician, right? If you started answering questions on your test, you're like, ooh, I know it's less than 10, right? What's 2 plus 5? I know it's less than 10. You wouldn't be wrong, right? But you wouldn't be that exact. So we want to get a little bit better at this. Well, if you're counting radians, which are these angles, and the radians are related to these arc lengths put together, what do we call this length? All the way around. Well, circle is the whole thing, but what do we call the distance all the way around? Circumference. Now, what do you know about the circumference of a circle? Circumference is 2 pi r. Okay? So you knew that your circumference is 2 pi r. What does it mean? What does that formula mean? What does the r stand for? Radius. Ooh, what's the plural of radius? Radii? Yay. Put 2 i's on there. Is that plural of radius? Right? Because platypus is platypi, and moose is meese, and all those kind of things. It's mooses. Anyways, doesn't matter. There's 2 pi radiuses around. If there are 2 pi radiuses around the edge of the circle, and every time we have a radius around the edge of the circle, we have 1 radian, does it make sense Does it make sense that there would be 2 pi radians in one circle? So now I'm going to get you to think in ways that you're not close. 6.28, right? Approximately, because pi is 3.14 approximately. So this would be approximately 6.28. Okay. Now, I'm going to get you to think here. How many radians is 180 degrees? Right? We now figured out that there are 2 pi radians in a circle. How many degrees in a circle? 360 degrees in a circle. So are you okay to say that 2 pi radians is equal to 360 degrees? That means that 180 degrees is how many radians? Half of that would be pi radians. We just need this to get into more sports lingo, and people would learn their radians really, a lot better. Like if they, like skateboarding competitions, and it's like, oh, that guy just did an amazing 4 pi, right? But they say things like 360 and 720 and stuff like that. But they started using radians, maybe people would be better at this. Not sure. So we can say that pi radians is 180 degrees. Using your knowledge of ratios, how did I go from here to here and here to here? What did I do? I divided by 2. Does that make sense? If 360 was 2 pi, then 1 pi would be 180. I want you now to tell me what exactly 1 radian is. And I can't write all the decimal places. Well, I can write an exact answer and then an approximation. Yes. 180 over pi. So 1 radian is 180 degrees divided by pi. And since pi is a little bit more than 3, and 180 divided by 3 is 60, you can see that this answer is going to be a little bit less than 60. Take out your calculator and give me 1 decimal place. What is 180 divided by pi? Is that 1 decimal place? 57.3 degrees. So 1 radian is approximately 57.3 degrees. And what we're going to do is now we're going to redo all the trig we've learned all the way through, but now we don't have to use degrees, we can use radians. We can do that. So on the next couple of pages, they explain the definition of a radian in your notes. Here we go. So we can highlight the official, if you want to highlight your official definition. Okay? So if you have a radius of r, the central angle of 1 radian is when you subtend. Do you remember that word subtend from grade 9 circles? Probably not. Subtend means that whatever angle it is cuts out that section or that arc of the circle. So whenever the arc has the same length as the radius, That's 1 radian. Okay. And then on, whoops, where is that big shaded part? On the next page. Here we go. There it is. So in this box on the next page, I want you to put a box around the fact that you will know that 360 degrees is equal to 2 pi radians. And from that, it's really easy to divide them both by 2 to find out that 180 degrees is equal to pi radians. Now, one of the interesting things that happens with radians is there's no symbol for radians, right? If you want to say 180 degrees, you have to write a little symbol like that. That means degrees. If you want to say pi radians, you just have to write pi. There's no symbol for radians. You don't have to write radians. So anytime you're talking about an angle and you don't include the degree sign, so one of the things that your teachers might have deducted you in the past is if like you forgot, yeah, like me, you forgot your degree sign. I might have taken off a half a mark if you didn't write the degree sign. Well, that's because technically when you write 180 degrees but don't include the degree sign, that's 180 radians. And 180 radians, times that by 57, it would be how many degrees that is? It's like 6,000 degrees. That is a really far off answer. That would be like if someone said, how tall are you? And you said 180, and they said feet, and you said, yeah. Right? That would be really far off if you use the wrong units. There's lots of places where if you use the wrong units, things could be very bad, right? If you go to buy something, right, and it costs $10, and you pull out 10 cents, that would not be good. Well, it'd be good for you, right? Or you go to a different country, and the currencies are different, right? And someone says they're going to pay you 10 an hour, but in Zimbabwean currency or whatever that is, it's not worth very much. Okay? Oh. So once you know that pi radians is 180 degrees, you could divide both sides by pi and figure out that 1 radian is 180 degrees over pi. Or you could divide both sides by 180 and figure out that 1 degree is pi over 180 radians. And those red and purple boxes can be very helpful if you had to convert, right? If I wanted to convert 90 degrees to radians, I could just take the purple box and multiply both sides by 90. And then I would have 90 degrees is equal to 90 pi over 180. I could also get 90 degrees by taking the blue box and dividing both sides by 2. So we can use these ideas to convert from one measurement to another. And that's one of the things you're going to do often at the beginning, because you're not going to be comfortable with when I say pi over 4 radians, you're like, what's that? I'm not used to that yet. But if I said 45 degrees, you're like, okay, I got that angle in my head. I can picture that. So we're going to be converting back and forth. The other thing that you did yesterday, or the day before, no, I think it was yesterday, is you came up with a formula for the arc length using ratios. So what we looked at, and when we did it with degrees. You said whatever angle you have out of 360 and arc length, steal some of this, there we go. for whatever reason they use the letter S for arc length. Your arc length was whatever angle you have out of 360 multiply by your circumference. Correct? Does that seem familiar from the activity we did yesterday? So if you had 180 degrees, well, that's half of your circumference, because 180 out of 360 is a half. If you had 90 degrees, that's a quarter of your circumference, because 90 out of 360 is 1/4. So now we can do the same thing and create an arc length formula if you wanted to use radians. And something pretty happens with the arc length formula if you're using radians. The idea is the same, arc length, and we're going to start by writing the same idea, but instead of theta out of 360, because that's degrees, I'm going to have theta out of 2 pi multiplied by my circumference. And normally I would say with both of these formulas, don't simplify, because if you didn't simplify these formulas, they really mean something. This is your proportion that you have of your circumference. So I really like keeping my formula this way. I don't even simplify the 2 and the 360 to become 180, because I think it makes more sense to write it as this is my proportion of my circumference. But with the radians, oh my, does that ever simplify so nicely? 2 pi on the top and 2 pi on the bottom, that the formula for arc length, just on your formula sheet too, for radians, just becomes whatever angle you have times your radius. Which kind of makes sense, because if you have an angle of 2 radians, that means that you would have 2 arc lengths along the outside that are both your radius. So your arc length will just be whatever your angle is times your radius. All right, so that is going to be our introduction to what a radian is.